I would like to introduce to you our Gapminder.org project, and this is just going to blow your mind. Get excited. Here we go. So it's going to be on ClassKick, where you do most of the stuff, and you're going to go to this site, Gapminder.org, specifically the part with the bubbles. Although if you want to play around with this site, you can look at all of this stuff that's on here, but we're going to do the stuff that looks like a bunch of scatter plots. Now, this site is awesome because it has so much data. Look at what we're looking at right now. We're comparing the income level per person in most countries in the world to their life expectancy. And look and see what you notice already, like what kind of association would you say that this is? And then we can kind of start playing around with whatever we want to play with. For example, let's say that I'm not as interested in income and that I'm interested in, I'm interested in math. Let's look at your math achievement in 8th grade as compared to your life expectancy. Let's look at that, guys. I feel like this is a thing we could affect right now. Here we go. There's fewer data points for this, so fewer countries must take data on this. But check out this scale. Awesome. Speaking of scales, when you do it, you're going to click on the axes and you're going to make sure that it's always selected on linear. A log scale is something different that has to do with exponents that you'll learn about maybe in 10th grade. But for now, you're going to make sure it's clicked on linear. And then you're going to look at the rest of the graph. Now, you could change the x-axis and the y-axis to whatever that you want. You can change the color of these dots. Right now it's by world regions, so like these green ones are North and South America, etc. But let's change it to, I don't know, do you want to change it to income, since we took that one away? Sure. Okay, and we can kind of notice then what income does to that graph. You can also change the size of the dots. Right now they're sized by population, but if you want to change the size of the dots to, I don't know what else you would, babies per woman. I don't know how that relates, but then the size of the dots changes in different ways. Okay, so let's say that I found this graph particularly compelling and interesting. I'm actually going to change that back to population size because that ends up making more sense to me. So population. Okay, so let's say you wanted to know what one of these points represented. You just kind of hover over the point. That big bubble right there that's green is Indonesia, and they have a typical math achievement of 405, and they have a life expectancy of 69 years. How about the United States? A typical math achievement of 508. I don't know what that means. Maybe it's a test. And then a life expectancy of 78. Notice this is in 2007. Also, this thing has a play button down here where you can watch this change over time. Interesting. So you can kind of look at that graph go. If we refresh it, because this graph is only so interesting, and we look at that original graph that we had here. Oh, no, it's not. If we look at the original graph that compares income and life expectancy, you can really see how that changes over the years by pushing that play button back from 1800. Oh, if you click on a country as you're doing this, like let's say that we want to look at Panama, because we're from Panama, or we live in Panama rather, we can literally watch, it'll trace Panama. Do you see this little tiny dot moving here? That's like tracing Panama over time. And looking at, looks like their income level is going up, but their life expectancy is staying pretty steady. We're in 1914, 1915, and then like look at everything else kind of change and bounce around it. Oh, now Panama's going crazy. So you can really like track data versus time, and you can wonder what happened right there in the 70s that made Panama's life expectancy go up so much. Very interesting. Cool. So you're going to play around with this for quite a while, and you're going to take screenshots of things that you find compelling, and you're going to put them right here. And this is just to kind of keep you in mind. I don't actually care how many screenshots you take here, 1, 2, 7, whatever you need, it's a spot for you. Then you're going to go on to part 2, where you're going to pick one scatter plot that you find super interesting. And you're going to take a screenshot of the scatter plot and paste it right here. You'll be using this a lot of times. So then you're going to compare the two variables that you find that you're comparing on the x-axis and the y-axis, and you're going to write it there. You're also going to tell me what other two variables you're considering. That means the color and then the size of the bubbles, and play around with those till you find it interesting. And then I want to know, why did you pick this data to compare? What do you think is interesting? Like, what have you grabbed someone from a different room and been like, hey, come look at this. This is fascinating. So then you're going to move on to the next thing. You'll copy and paste that same scatter plot below. You're actually going to do that like 5 times. You will draw in a green line of best fit using this line button next to the T on ClassKick, just like we've been doing for the past couple weeks or so. You're going to be figuring out what the rate of change is and what it means. Remember your units. Same with your initial value and what it means. And finally, you'll be writing your y equals mx plus b equation for that line of best fit that you draw. If you want an example of that, I did one right here where I have my scatter plots and then I have my line of best fit. I drew my slope triangle and I identified my rate of change. Okay, then you're going to start thinking about what kind of association. Again, copy and paste the scatter plots. Again, does your data show positive, negative, or no association? And you can definitely, please do, use this sentence frame to kind of frame your thinking there. Does your data have linear or non-linear association? How can you tell? Does your data have strong, weak, or moderate association? How can you tell? Again, copy and pasting the scatter plot, you're going to do some interpolation and extrapolation. So you're going to pick a point that is important to you, and you're going to make a prediction from your data. You'll copy and paste your line of best fit equation, and then you'll answer the following questions. Use the data to make 2 predictions, one that's inside the data set and one that's outside the data set. Both should be in the form, if a country had an X value of blank, a statistician might expect the country to have a Y value of blank because, and you're going to make an argument here. So what this kind of looks like in my example is I picked an X value of 3, and then I calculated it with my line of best fit. Then I actually picked an X value of 20, which this is only 14, so 20 would be way over here somewhere, like right there. And I figured out what the life expectancy would be there. Okay, next, and finally, for most of you, you're going to be copying and pasting your scatter plot again and making some claims about it. So you'll look through the data and you will find Panama and at least one other country of your choice. If you don't have Panama, pick 2 countries. You'll point them out on the graph by circling or drawing arrows, and then you'll conclude what conclusions can you make about Panama from this data, and what conclusions can you make about the country of your choice from this data. So when I did this on my example problem, I looked and saw, I wrote a lot here actually. I wrote what Panama's point is, I wrote what Panama means, I wrote that where it was in relation to the line of best fit, and kind of what it meant for Panama to be there. And then I did that for my other country as well. Next, what conclusions can you make about the data in general? Do you think your data has association, causation, or both? This is really where I want you to get into. Does the x-axis variable, does it cause the y-axis data variable? And that's a pretty big claim to make. So on mine, I was debating whether or not the number of years in school for women actually causes a higher life expectancy for women. And I didn't think that, even though I have definite association here, I didn't think that I could really make that claim. Okay, 3 more things. You're looking for possible lurking variables from our last lesson. You're wondering what this data might mean for the world, and how might someone misuse or misinterpret this data? Because all the time we have politicians and people all over the place, teachers even, nice people like us, using data to make claims. So what true claims could they make, and what false claims could they make? I'm really interested to see what you write here. If you want examples of that, check out my example video. Finally, if you are looking for the extending part, it is optional. It is on this last page with the polka dot background, and I'll let you read the directions for that. But again, this is optional for you. Thank you so much. Good luck on your project. Let me know how I can help.